I hope that's recording. Okay. All right, everyone. So let's go ahead and get started. If you need me to slow down, just type it in the chat. Hey, sir, can you slow down? I need a minute. I need more time to write. So definition, an exponent. An exponent is a shorthand notation to write repeated multiplication. So for example, we have 3 times 3 times 3 times 3 equals 3 to the 5th power. The 5 guys, go ahead and draw an arrow. That is going to be the exponent that we're talking about in the definition. Whereas the 3 is called the base of the exponent, the base of the number. You guys need to be comfortable with the terminology that we will be learning in this class. I expect you guys to write these down and to ask me questions. So in this box below, you'll see that expression and in words. So since this is elementary algebra, I'm going to go ahead and kind of ease your way to the college level math so we can be kind of confident in ourselves. So 5 is the base and the 2 is the exponent. There's 2 ways to read this expression. We have the 5 to the 2nd power, or another way to write when the exponent is 2, ladies and gentlemen. Does anyone remember what we call the exponent 2? 5 what? 5 squared. So for example, 5 to the 2nd power or 5 squared. And then we have the next exponent 3. That we could say 5 to the 3rd power or 5 cubed. And after that, 5 to the 4th will be 5 to the 4th power. Does anyone want to take a gander or a guess of how we're going to pronounce this? 5 to the 5. How will we pronounce that in words?
5 to the 5 power.
You sure? Look how we look at the numbers here. We did 2nd, 3rd, 4th. Will we say 5 power, or what's another way we can say 5?
5 to the 5th power.
5 to the 5th power. That is correct, guys. 5 to the 5th power. It's kind of like the way the grades sound in school, like 5th grade, 6th grade, 7th grade, 5th. So it has to have the TH in there. Do y'all see the difference from the 5 to the 5 power and send 5 to the 5th power? So you guys want to be comfortable with reading that notation. So when y'all see exponents moving forward in this class, I expect you guys to be able to express and read it correctly. Like for example, I'm gonna give you one more before we move on. What about right here? How will we say this exponent here?
9 to the 7th.
9th to the 7th power. Thank you, Yvette. That is correct. So does everyone understand how to read exponents so far? If you have any questions, please ask in the chat, or you can unmute yourself and ask me or the class. Now look at this note, guys. So I'm setting you up this class in case some of you guys want to become engineers or accountants or something that's in mathematics or in STEM. So DEF, guys, this is what we use in college math. Since I have a degree in mathematics, we see this a lot in all the other math classes. DEF is short for definition. And then we have this word note. So notes are kind of like me telling you important facts about mathematics, about the lesson that you're going to need to utilize in this class or possibly in the assignments. So an exponent of 1 is never written, guys. So notice how we started at 5 to the 2nd power. So any number or variable by itself has an exponent of 1. Like for example, if you just see 7 by itself, it's actually 7 to the 1 power or to the 1st power. But we never say it. Just like for example, the number x. What number is in front of this x that we never see? X is the same thing as 1x. So notice how whenever we use the value 1, it's always invisible. We never write it, the 7 to the 1 or 7 or 1x. 1 is because 1 is such a basic number. Because when you multiply 1 to anything, it's the same thing. 1 times 3 is 3. 1 times 5 is 5. 7 to the first power, 7. So, oh my bad, this is like a 0. These are not 0. They're just invisible, just showing you that there's nothing there. But I just realized it looks like a 0, so I'm gonna erase that. But all right, does anyone need an extra 30 seconds or minute to copy this slide, guys? Does anyone need more time? All right, let's keep going. So example. So I'm gonna go ahead and give you a minute to write the word examples, write the instructions, and then write number 1, 2, 3, 4. Number 1, 2, 3, 4. Now remember, I'm gonna go ahead and give you a timer. I'm gonna give you a 1-minute timer. If y'all need more than 1 minute, I'll add another minute. So remember, we use exponents to write repeated multiplication, guys. We use exponents to write repeated multiplication. So if you want to try to do these on your own before I get started, I recommend that. If you're using pen and you're not confident, I would recommend switching to pencil when you're trying to do something on your own that you haven't learned yet. Now, when you're doing this, you're gonna want to look, you want to find the base. You want to find out what the base is, and you need to find out what you think the exponent is. That's what you need to do for all these 4 problems. All right, that was a 1-minute timer, everyone. May I begin the examples, or is anyone still setting up? Would anyone like an additional 30 seconds or a minute? Okay, so look at number 1. Number 1 says 7 times 7 times 7. So it's repeated multiplication. We're multiplying 7 multiple times. So when you see that number, guys, that's 7, that's going to be the base. Whatever is being multiplied is going to be the base. And now, how can we determine the exponent, ladies and gentlemen? Does anyone want to take a guess of what my exponent is going to be here?
Would it be like counting like the 3 numbers or like 3?
3, right? Oh,
Yeah,
yeah,
three.
because how many 7s do we have?
3.
3. So it'll be 7. How do we read this, ladies and gentlemen?
7
7
cubed.
to the third
7 cube or 7 to the
Third
third
power.
power.
to the 3rd power. That is correct. All right. And then we're done with number 1. Number 2. What's going to be my base for number 2?
3,
3
Excellent. My exponent?
2,
squared.
cube,
2. So how will we pronounce that? 3
3 squared.
or
3 to the 2nd power.
excellent. Now let's move on to number 3. Number 3, what's my base?
6.
Excellent. And then what will be my exponent?
5.
And how do we pronounce that?
6 to the 5th power.
Excellent, guys. 6 to the 5th power. So make sure now you don't have to. I appreciate you unmuting yourself and sharing with the responses to the class. If you're not comfortable doing that yet, do it to yourself. You're muted. I'm not going to hear you, but you say it to yourself in your room, whether you're in the kitchen, the dining room, the library, Starbucks. I don't care. Participate, guys, because if when you do what I ask, I promise you, you will pick up this much quicker. All right, number 4. Ooh, the plot thickens, everyone. Why is that? How many bases do we see?
2.
2. Excellent, Sarah. So the first base that we see is what, ladies and gentlemen?
3,
The 3. So we're gonna write 3. Now, what's gonna be my exponent for the 3?
4,
Excellent. Now, what operation is this dot?
multiplication.
As multiplication. So we're gonna keep that multiplication there. And now what's gonna be the next base that we write or include?
9.
9. And what exponent for that?
3,
3. So now how do we read this? Now, every time we have a question, guys, I want you to box your answers in this class. You want to make it a good habit to always box your final answer. So this would be pronounced as 3 to the
4th power.
times 9
to the 3rd power.
to their power, and we're done. Now, in this class, guys, as me as a teacher, I'm very into forcing you to try to do this on your own during my class. So underneath examples 1 through 4, I want you to write practice 1 through 4. Now, you could rewrite the directions if you want, or you cannot because you already wrote them for the example up here. And I want you to do number 1, 2, 3, 4 on your own, on your notebook. This can be done in your lecture notebook. For those of you guys that just chimed in right now, we're barely on the first example, guys. I am recording this video and I'm hoping to be able to upload it on Canvas for those of you that missed the early lecture. Guys, for those of you that started with me from the beginning, how much can the students skip on their notebook or paper so they can start where we are at? Would you say half a page, a full page? So
About
anything more
halfway.
than half? All right, guys, for those of you that walk in, I will go a little bit underneath halfway and start these examples, guys. I'm gonna give you about 1 minute on this practice problems, just because they're very basic problems so far. All right. Was 1 minute enough for you to tackle these 4 practice problems, guys, or do y'all need more time? Okay. Would anyone like to share their answer for number 1?
I got the number 1. I got 8 to the 4th power.
Does anyone agree or disagree with Iris?
Agree.
Agree. If your camera's on, a thumbs up is cool for agree. Thumbs down can be a disagree. All right, that is correct. Good job, Iris. All right, 8 to the 4th is correct. What about number 2, ladies and gentlemen? Does anyone want to take a gander at that? What do y'all think number 2 would
3
be?
cube.
3 cube. Does anyone want to challenge 3 cube for number 2? Does anyone know another way to say it?
Third power.
3 to
3
the 3rd power. Correct, Carly. All right, we're on number 3 now. What's number 3 on this practice problem, ladies and gentlemen?
10 to the 5th power.
10 to the 5th power. Loved how you pronounced it. That is correct. Ooh, number 4, guys. The plot thickens. Do I have any daredevils that wants to share with their class what they thought number 4 was?
Was it the 5th cube times 4, 6?
So take it. Okay, so it starts first. So 5 to the what first?
5 cubed.
I heard 5 cubed times 4 to the what?
4 to the 6th power.
Does anyone agree or disagree with Iris?
Disagree.
Okay, Yvette, what's your disagreement? What do you think it is?
She's close, but it's feel like for the base it's 5, right? But there's 2 5, so your exponent will be 5 to the 2nd power.
You see that, Iris? There's only 2 5s, so it should be 2. The exponent should be 2, ma'am.
Yes.
All right, and then it's 4 to the 6, correct?
Yes.
There we
Okay.
go, and we're done. Are there any questions on writing exponential notation, everyone? Any questions? All right, let's keep going. Your hands are gonna get a workout today, guys, and I say this with love. All right, here's the next set of examples, guys. Now we're gonna evaluate. So when you read an exponent like 5 squared, 7 squared, 7 cubed, 9 cubed, 3 to the fourth, that's an exponent notation, but it has a value. These numbers have values. Our goal here is to find those values. So let's look at number, I'll give you a minute to set it up first, a minute to set up, my apologies. And then sometimes, if y'all notice, I was gonna jump in right now. I love mathematics, guys. So when I get into math, I kind of go 100 miles per hour. So if I start an example without giving you time to write, call me out. Be like, sir, you didn't give us time to write. And then I'll be like, oh, my bad. And then I'll just let y'all write. Testing, testing. I'm switching to my headset, guys, just because I do have a toddler at the house, and I would rather, I'd be embarrassed if you heard his scream. Just this dude's dramatic. Okay, can you guys hear me with my headset? Okay, that was my timer, guys. Was everyone was able to set up the examples so we can begin? All right, let's get started, guys. So 9 to the second power, or 9 squared, is the same thing as 9 times what? 9, right? 2 times, 9 times 9, 2 times. Well, this now brings out the multiplication that you need to work on. So 9 times 9 is just what, ladies and gentlemen?
81.
81. So the answer to this one is 81. Now, just because you're getting ready for college level math, guys, let me make you understand something. You do not have to be a human calculator. You do not have to be able to do 9 times 9 in your head. Would it be helpful? Yeah, but do you have to be? No. And by all means, I'm not forcing anyone to be a calculator in this class. So if you want to pull up the calculator for this part, I do not judge. Now remember, number 6, it's 6 to the 1 power. So if it's 6 to the first power, how many 6s are we going to evaluate?
1.
And what's the value of 1 6?
6.
6. Yep. That's correct. Everyone with me so far? All right. Number 7 is 3 to the, how do we pronounce number 7?
4th power.
3 to the 4th power, which is 3 times 3 times 3 times 3, 4 times. So let's multiply from left to right. 3 times 3 is 9, times another 3, 27, times another 3, I believe is 81. And we're done. So we're just multiplying it across. Now we're on number 8. 5 times 6 squared. Now, whenever you have two different bases, guys, I highly recommend that you do the exponent first. So 6 squared is 6 times 6. Can anyone tell me what 6 times 6 is?
36.
It is 36. So then we get equals to 5 times 36. Remember, guys, you're not a calculator, so you don't have to do this in your head. So in your journal, you can just do 36 times 5, or you can type it in your calculator if you have one accessible to you. 5 times 6 is 30. Carry the 3. 5 times 3 is 15, plus 3 is 18, which is 180. Did anyone plug it into their calculator? Can they check with me?
Yes, is correct.
Thank you, Carly. So, and we're done with the examples 5 through 8. Are there any questions with how we evaluated these exponents, guys? Any questions? All right, you guys ready to try the practice problems on your own? All right, I'm gonna go ahead and give y'all guys 1 minute. If y'all need more than 1 minute after the minute timer, I will just ask if y'all need more time. Good luck, everyone. my biggest advice is when you're doing the practice problems, I recommend that you write down the exponential expanded out. How many times is the base being multiplied and then multiply. All right, ladies and gentlemen, a 1 minute timer was expired. Do I need more time? Okay, I'm gonna give you 1 more minute, all right? Bless you, Sarah. All right, 1 more minute, guys. Good luck. All right, guys, that was the timer. Let's go ahead and get started on number 5. Hopefully I can finish the rest as we go through 5, 6, 7. All right. Number 5, can someone pronounce how to read the notation in 5?
4 to the second power.
That is correct. 4 to the second power, which is just what times what?
4 times 4,
Excellent. Which gives us what?
16.
That is correct. And we're done. Now, do I have a volunteer for number 6? How do we read number 6?
7 to the third power.
Excellent. And when we expand it, what would it look like?
7 times 7 times 7.
That's correct. And when you multiply that out, Carly, did you get the value? What'd you get?
343.
Excellent. Does anyone agree or disagree with Carly?
Agree.
Excellent. Anyone want to tell me how you would just read it, number 7?
11 to the first power.
11 to the first power. And to evaluate that, guys, what would that just equal to?
11.
Excellent. Now let's see if you guys who can read number 8 for us out loud.
2 times 3 to the second power.
That is correct. And then when we expand it, what would it be?
2 times 3 times 3.
That's correct. Now, which one would you multiply first?
3 times 3.
When you get 2 times 9. And the final answer will be?
18.
Yep. And we are done. Are there any questions, guys, on evaluating exponents? Everyone okay so far? All right. Am I able to move on to the next slide, guys? Is anyone still ready? All right. Here is the next slide. Now, this slide has the order of operations, guys, which is Pemdas. I'm gonna go ahead and give you about 2 minutes to write down this slide.
All right. Does anyone need more time than that to write these steps down or this slide? All right, I'm going to get started. So the order of operations, guys, is actually how we do arithmetic. Now, arithmetic and mathematics is just basic operations. Add, subtract, multiply, divide, exponents, etc. Now, parentheses of the, so you always want to simplify. If you see any pairs of parentheses, we simplify the inside of them. And now there's not just parentheses, so we have parentheses, right? We have parentheses, we have brackets, and then we have curly brackets. So go ahead and write these symbols next to the first step because it's going to be any of these symbols. They're all treated like parentheses. Number two, we're going to evaluate any exponents. There's a typo. Let me fix that. Exponents. I'm sorry, guys. I hope you didn't write my misspell of exponents. I'm not an English person. That's why I teach math. But I caught it. Exponents. And then number three, we multiply. The key word for number 3 and 4, guys, is multiply and divide. Add and subtract from left to right. Those are the key terms in the steps 3 and 4. Be prepared to be mind blown, ladies and gentlemen. Example, simplify the expression. Let's look at A. A says 2 times 4 minus 3 divided by 3. Have y'all seen those memes like that's being shared on Facebook, Instagram, like social media that's like, what is this equal to? And people are like 16, 1, 16, 1. And there's all this. Yeah, you use this to simplify those memes, guys. So now you're gonna be able to be a meme checker. Then you can add that to your resume. Yes, I check memes with expressions. I know PEMDAS. I'm just kidding. All right. A. Are there any parentheses in PEMDAS? So I like to write PEMDAS going vertical like this, PEMDAS. So this is my checkpoint. I'm going to use these letters to check through the steps of orders of operations. Are there any parentheses or grouping symbols in A? So we're done with P. P's done. Are there any exponents in A to evaluate? No. So we're done. Can we multiply and divide? Yeah, we multiply and divide from where? Left to right. So we're going to multiply 2 times 4, which is 8. Bring down the minus, and then 3 divided by 3. What's 3 divided by 3, y'all? 1. Now, do we see any more multiplication or division? So this became the 8, and then this became the 1. So we're done with M and D. And those are arrows. And the last thing we do is add and subtract from left to right. 8 minus 1 is just what? 7. And we're done, ladies and gentlemen. You just did order of operations. All right, ready for B, ladies and gentlemen? Remember our checklist. Are there any parentheses or P's or grouping symbols in B? No. Are there any exponents we have to evaluate for B? Yeah. What do we evaluate, guys?
4 times 4.
Yep, which is 4 times 4 is
16.
correct. And then bring down everything else, guys. Bring down everything else. This topic is going to be a little annoying because you are going to be writing multiple steps for each expression. I don't want you to jump the ball and do multiple steps at once, because when you do more than one step at once, it causes confusion. So now we're done with parentheses. And we're done with exponents now because there's no more exponents here. What's the next step we're going to do, ladies and gentlemen?
divide because it's
Ah.
on the left side.
As on the left side. So we're gonna do 16 divided by 2, which is what? What's half of 16?
8.
8. And then bring down the times 4. The 16 divided by 2 is 8. Bring down the times 4. And to finish this off, 8 times 4 is 32. And we're done. Does anyone have any questions on how we use the order of operations on this example? We're gonna be doing a couple of these so we can get comfortable with them because it's probably been a while, right, since you have done math like this. So let's try again. Let's try some more examples. Example C. It's the same direction, simplify the expression. As you see, as my examples are getting more and more complicated, you see that, right? Well, hate to break it to you guys, math is complicated. So get ready to be exposed to some complicated crap. I'm gonna go ahead and write Pemdas. P E. Now you don't have to do this checklist with me, but it's something that I picked up since high school, and I've always been comfortable at order of operations. So let's say I wasn't here. You had to do this example by yourself. So what would you do first, guys? What's the first step of the order? The parentheses. What's inside the parentheses that we have to simplify?
8 minus 6.
Which is 8 minus 6?
2.
Which is 2. So then we write 2 and bring down everything else. 2 squared plus 2 cubed times 3. Excellent. So no more, the parentheses are gone now. So we're done there. So now E, do we have exponents to evaluate here?
Yes.
Yeah, 2 squared. What's 2 squared, y'all?
Before.
Yep, it's 4. And then bring down the plus. Can someone tell me what 2 cubed is?
Would be 8.
It would be 8. And bring down the times 3. Do y'all see how it's coming down to like a little triangle, like a pyramid a little bit? Every time we do a step, it's getting smaller and smaller. So now we're done with exponents. No more exponents to evaluate. So now what step are we going to do next, guys? What's step 3 in the order of operations?
Multiplication.
So which one are we going to multiply? 4 and 3 or 8 and 3?
8 and 3.
8 and 3. And what's 8 times 3, y'all?
48.
Nope. 8 times
Okay.
3. You're good.
24.
24. So we're done with multiply and division. The final step we're going to do is add and subtract, which is 4 plus 24 adds up to what?
28.
28. And we're done. Are there any questions on how we evaluated this one or simplified this one? All right, I'm gonna go ahead and give you do y'all guys need like a 30 seconds to write letter D down? Let me give you 30 seconds. That wasn't the timer. I just changed the tone. My bad. Ooh, D gets a little complicated. All right, for D, ladies and gentlemen, let me go ahead and write my checklist. Again, P, E, M, D, A, S. All right, guys, are there any parentheses we can simplify the inside? What's different about letter D to C?
It has brackets.
It has brackets and parentheses. Red flags, guys. Nah, I'm just kidding. That's not red flag. It's doable. So which one do y'all think we can simplify first? The brackets or the parentheses?
Parentheses.
The parentheses, that is correct. So we go now. Let me just explain this. That way you know, because in case the homework has like a tough problem. If you have, let's say there was more stuff inside this printed. Let's say it said 10 divided by 2 minus 5 plus 7. You know, it had all this stuff. You would do the order of operations inside of the parentheses again. So you'll go inside the parentheses and pretend it's its own expression, and you'll do Pemdas to get it to one number. But since this one doesn't have a lot of steps, it only has one thing. It has 10 divided by 2. What's 10 divided by 2? 5. So bring down everything else. 3 squared brackets minus 7 times 3 plus 4 cubed. Notice how I dropped the parentheses because we now have just one number. Now, if there is a number in front of the parentheses, like there was a 2 here, I will keep the parentheses with the 2. Like if there was a number in front of here, but that's just showing you different scenarios at that point. Okay. Now I can't check off P yet because we still have brackets there. So now we're gonna do we're gonna do order of operations inside the brackets. So what do we do first? Do we do 3 minus 5 first, or do we do 3 squared first?
3 square.
Excellent. What's 3 squared?
9.
Yep. So then we get bracket 9 minus 5 bracket minus 7 times 3. Can we now evaluate the brackets? What's 9 take away 5?
4.
Yep. Question, ladies and gentlemen, do I need to keep the brackets now?
No,
Why not?
because we solved it down to just one answer and one number.
That is correct. Thank you, Yvette. So now we can check off the letter P. We're done here. Is everyone with me with how we're doing the steps now? Everyone good? All right. So now after P, we have exponents. Do we have any exponents to evaluate?
Yes.
Yeah, we have 4 to the 3rd power. What's 4 times 4 times 4?
64.
64. And then bring down everything else. Now we do multiply and division. Where do you see multiply or division in this last line so far?
7 times 3.
Which is what?
21.
21. So it'll be 64 plus 4 minus 21. And now we're done with multiply and division. And now we end it with adding and subtracting from which way to which way? Left to
Left
right.
to right.
What's 64 plus 4?
68.
Then we do 68 minus 21, which equals to what?
47.
47. And we're done. Are there any questions with these two examples, guys? All right, let's keep going. These are the last two, I think. So I'm gonna go ahead and give you 1 minute to write these down.
Excuse me, sir.
Yes.
I'm on the road right now. Is it possible just to screenshot the questions and then do them when I stop?
Sure.
Thank you.
All right. So for letter E, guys, it's a fraction bar. We have a top and a bottom. So whenever you have a fraction bar for order of operations, you want to simplify the top and the bottom separately. That's the biggest key thing here. So you're gonna see these again. So we're gonna do the top and the bottom separately using Pemdas. So let's do the top first. So write TOP, the top. So it'll be 7 minus 2 times 3 plus 3 squared. So if you're simplifying the top first, are there any parentheses to simplify? There is not, so we're done with P. E, we have exponents. We have 3 squared, which is 3 times 3, which is 9. So it'll be 7 minus 2 times 3 plus 9. So we're done with exponents. Now we're gonna multiply and divide from left to right. 7 minus 2, nope. 2 times 3 is 6. So I did 3 squared first. Now I'm gonna do 2 times 3. So it'll be 7, take away 6 plus 9. Now we add and subtract from left to right. So then we get 7 minus 6 is 1 plus 9. It's 10. So now we're done with the top. So we get equals to 10 on top. Now we're gonna do the bottom. I'm gonna switch my color. So bottom is gonna be 5 parentheses 2 minus 1. So we're gonna do the parentheses first, P. 2 minus 1 is 1. So we get 5 parentheses 1. And then we do multiply, divide. 5 times 1 is just 5. So now we get 10 divided by 5, or 10 over 5. 10 over 5 is the same thing as what? It's 2. So we're done.
It's like dividing, right?
It's just like dividing. Yes. And that's another note we want to write. So another note, no. Fraction bar is another way to divide. Another way to divide. All right, F.
Can you just hold on for 1 second? Because I'm just copying all this.
Oh yeah, of course, of course.
Okay, thank you so much.
For those of you that are waiting, guys, I recommend doing F on your own with Pemdas, trying to see if you can do it on your own. And let me know when you're good to go, Sarah.
Okay, I'm good to go.
Okay, thank you. Anyone else need more time, guys, before I do F, the final example for this lesson? This not lesson, but this section. Okay, F. Are there any parentheses to simplify? No.
No.
Any exponents?
No.
So the first steps are done. So the first step we start with is what?
Multiplication,
And
division,
from left to right. So what do we do first? Do we do 8 times 2 first or 64 divided by 8?
64 divided by 8.
That is correct, which is just another 8. So 64 divided by 8 is just 8. Bring down everything else. Then we do 8 times 2, which is what?
16.
Excellent. Bring down the plus 4. Add these together and we get,
20.
and we're done. All right. Would anyone like to work on some practice problems before we move on to the next section? Because this is the end of 1.8. So I do have practice problems we could practice on, but if everyone feels confident, we don't have to practice on them. How does everyone feel? All right, ready? Here are your practice problems, guys. We have 6 practice problems. And it's gonna be simplify the expression. I'm gonna go ahead and give you guys about, I wanna say 10 minutes or 5 minutes. You wanna just start with 5 minutes? Miranda feels good about it. That's good. I'm gonna give you about 5 minutes on these example problems, guys, these practice problems. While I do that, I'm gonna go try and make myself a cup of coffee. All right, guys. So it's been about a little more than 5 minutes. Would you guys just want me to give you all the answers for each one to check your work? Would that be the easiest thing to do? And then I can go over any problems you need help with. So number one, answer to number one is 25. Number two is 64. Number three is 99. Number four is 61. Number five is 7. And 6 is 23. Does anyone want more time to practice on these? Was 5 minutes enough to get through them? Y'all need another 5 minutes? Talk to me, guys.
Can I have another 5 minutes?
Of course, of course, of course.
Yes.
Yes, I know I did provide the answers. That doesn't mean that you stop working and just write what I write. The goal of this course is for you to gain the skill sets to get to the answer on your own. So if you get it right, think of it as a proud moment if you're able to evaluate it to these values. If not, then you can look at your work with all the steps that you've been practicing writing with the notes to see, okay, where did I make my mistake? All right, good luck, guys. The 5 minute timer started.
Hey, sir, I have a question.
Yeah, what's up, Sarah?
So on the first one, it would be, um, there's no parentheses, there's no exponent, so then it would be multiply and divide, right?
That's
So
correct.
so first 9 times 3,
Mhm.
so would it be 9 times 9 is 81?
Ah, you're doing 9 cube. Is it 9 cube or is it 9 times 3?
Oh, okay. So 9 times 3. Okay, I got it. Thanks.
Anytime. I'm here. I am here, guys. My camera is off just because I'm drinking coffee and I don't like coffee, so my faces will be kind of funny. So I'm just gonna turn off the camera. Let me know if you need anything. All right, guys, that was the other 5-minute timer. I'm not that I'm rushing you guys because we still have a good amount of time class, and I have one more section to go over. I think we'll be okay with timing. Are there any questions so far? Any of these practice problems? Would anyone need an additional time? I don't. I don't mind giving. How many more do you need left? Like,
I need 2 more.
so you think 3, 4, 5 minutes? What do you think would be an extra? This would be the last time group of time I can give you. So 3, 4, or 5.
Like 4 minutes, if that's okay with everyone.
Yeah, say 4, or does anyone want to say 5, guys? All I need is one person to tell me 5, and I'll give y'all 5. Sarah said 4, so I can give y'all 4. If someone wants to say 5, I can give y'all 5.
I think 4 is good.
Yeah.
Fourth. Okay, I got you. 4 minutes starting now. Good luck, everyone. All right, guys. So that was a 4-minute timer, but I do have to do attendance. So I'm gonna go ahead and do roll call, guys. Make sure you unmute yourself and tell me here, or type here in the chat. If I butcher your name, please correct me on the pronunciation so I can understand how to say your name correctly. Sarah Adair,
It's Adair.
hey there.
Here.
Sarah Adair, okay. Gabriel Alvarez. Gabriel Alvarez. Okay, here. Francisco Castillo.
Here.
Iris Cooper. Iris.
Is there?
I'm just doing attendance right now.
Okay.
Manuel Herrera.
Here.
Valishka Cueva.
Here.
Kelsey.
Here.
Clarissa.
Here.
Bruno.
Here.
Nicholas.
Here.
Isabel.
I'm here.
Amia. Amia Lewis.
Here.
Excellent. Miranda.
Here.
Caleb.
I'm here.
Jean.
Here.
Yvette.
Here.
Emmanuel Rivas.
Here.
Sarah.
Me.
Yeah. No. Sarah Rodriguez. Sanchez. Sarah Rodriguez Sanchez. Kayla.
Here.
Mariel.
Here.
Ivan. Ivan Smith. Last call for Ivan. Carly.
Here.
Gregorio. Christopher. Chris Sarazua. Emily.
Here.
Excellent, guys. Excellent. Excellent. All right. So I'm gonna re-say the ones that were absent. Gabriel Alvarez. You sure you're not here, Gabriel? Sarah Rodriguez Sanchez. Ivan Smith. Gregorio. And Chris. I'm sorry, I cut off. Who was that?
Greg.
Greg? Okay, cool.
Yeah.
Okay, Greg's here. All right, that's 4 people absent. Not bad. Okay. All right. All right, let's get started. All right. Were there any questions on any of these expressions before we move on, guys? Oh, Sarah's here. Sorry, Sarah, I didn't see the chat. My apologies. Thank you. Let me go ahead and change that attendance. courses. All right. Now, before I move on to the next section, guys, are there any questions on these exam practice problems? Like anyone that got stuck on something that you're not, the step that you weren't comfortable with, anything y'all want me to help you out with before we move on?
I just had a quick question. It doesn't matter if we start on the top or the bottom, number 5, right?
Nope, it does not. As long as you get down to one number on either one for both top and bottom, doesn't matter which one you start. Great question, Sarah. Any other questions before we move on, guys? Any questions? All right, let's get this show on the road. Let's get this last section in. 1.8, guys, 1.8 is intro to variables, algebraic expressions, and equations. I'm gonna go ahead and give you guys about 2 minutes to write down this slide into your notebook. Then we'll get started. So the way this note works, guys, so the definition of a variable is an unknown value that's represented by a letter. Definition of an algebraic expression is a combination of operations on letters and numbers. So the one that 1.7, we just did regular expressions. Expressions were just a combination of operations with numbers. That's it. Algebraic expression, we now have letters involved as well. Now note, if a number and letter or two letters are next to each other, we can assume they're being multiplied. Like 4x, guys, 4x is actually 4 times x. XY is the same thing as x times y, or we could do x parentheses y, 4 parentheses x. Those are all different ways we can denote multiplication. We have the dot and we have parentheses, guys. We're no longer using that times the times table, the time symbol from elementary, like 2 times 3, we're not gonna use this anymore. This is no longer relevant in this class or in math. Like you could use it, but you don't want to confuse yourself because that looks like what letter? We do this. Now, people can confuse this as the letter X. So please be careful. So try not to use that symbol moving forward. Use the dot or use parentheses. Use the dot or use parentheses. Are there any questions with what's on this slide? All right. Does anyone need more time before I move on?
I do.
Would you like
Yeah.
another minute or two?
A minute.
All right. I'm gonna
Like 2
start.
minutes.
2 minutes. I got you starting now. All you have to do, guys, is ask. Ask for more time and I got you. Good luck. And then we'll move on. All right, guys, that was a 2-minute timer. Is everyone good to go?
Yes.
Excellent. All right, I'm gonna go ahead and give you guys a minute to write down example 1. Example 1 says evaluate x plus 6 if x is 8. Now the algebraic expression here in this example is x plus 6. This is the expression, and wants us to evaluate it when x is 8, if x is 8. X is 8 is the same thing as saying x is equal to 8. So this isn't an equation yet because there's no equal sign in the expression. It says x plus 6. But they want us to find out what it is. This is a colon when x equals 8. So all we do is substitute. Instead of x, I'm going to write the number 8 plus 6. And what's 8 plus 6? This is just like order of operations. 8 plus
14.
14, and we're done. Now it's only simple because the expression was very easy to start with. It's gonna get a little bit more complicated as we move forward in the class. So in this lecture, so go ahead and try practice one out by yourself. So evaluate x minus 2 if x is equal to 7. Now after you do the practice problem, please write this note in your notebook. X is 5 can also be written as x equals 5. So I'm gonna go ahead and give you guys a minute and a half to do this practice problem and to write the note. Good luck, everyone. All right, guys, that was the minute, that was the timer. So what'd y'all get for practice one? Would anyone like to share?
I got 5.
Does anyone agree or disagree?
I agree.
Excellent, excellent, excellent. It's cool. All right. Anyone need more time to write down the note? Or are we good to move on? Here is example 2. Now it gets a little bit more interesting because the expression gets a little more complex. Go ahead and give you guys 2 minutes. And now I want you to use Pemdas to evaluate. Always use Pemdas. Example 1, you didn't really require Pemdas because it was just something plus something, something minus something. It was very simple. Now this one has more than one operation now. All right, let's see how you guys did. So we plug in X and Y, so then we get 2 parentheses, 6 minus 3 parentheses. And now we simplify using PEMDAS. So to simplify example 2, what did y'all do first, guys? 2 times 6, or did y'all do 6 minus 3?
6 minus 3.
Excellent, which is
3.
3. Now, notice how I kept the parentheses. I kept the parentheses because what operation is a number next to another number with parentheses?
Multiplication.
Excellent. And 2 times 3 is 6, and we're done. Did I give you enough time to do the practice problem as well? Or is anyone still working on it?
I'm still working on it.
Got it. I'm gonna give you guys another minute. All right. Let's go ahead and look at this example 2. Okay, let me explain the example one more time, and now I'll talk about the practice problem. Okay, guys. All right. So in example 2, we have evaluate 2 parentheses x minus y for x equals 6 and y equals 3. So this is here the 2 and the x minus y. That's the algebraic expression. So we wrote it down, colon, the 2 variables that we know. I'm gonna go ahead and plug in 6 for x and y for 3. So I get 2 parentheses 6 minus 3. And then we use Pemdas to simplify this expression once we plug in the values. We do parentheses first, which is p. 6 minus 3 is 3. There's no exponents. And then remember, parentheses is another way to multiply. So 2 times 3 is 6, and we're done. So the answer was 6. Now we apply the same process here to practice problem 2. We have x and y. So instead of y, it'll be the value 4 parentheses x minus 3, but x is 8. So it'll be 8 take away 3. And now we use Pemdas to simplify this problem, which is p is parentheses 8 minus 3. Everyone, what'd you get for 8 minus 3?
3.
8 minus is not 8 minus 3 isn't 3.
5.
5. Did you see that? Because you have 8 and then you get rid of 3, you have 5. And then what's the final step? What do we do with the 4 and the 5, ladies and gentlemen?
4 times 5,
Yep, which is,
20.
and we're done. All right, guys. Any questions on example 2 before we move on, guys? Any questions? So it's kind of interesting that it's a new topic, but it's very similar to the last lesson, correct? Where we're doing Pemdas, which is what we just learned. All right, let's see how it keeps going. So example 3. I'm going to go ahead and give you guys a minute to set up example 3, and then we'll work it out together. And I'll give you some time to do the practice problem. So example 3 is evaluate x minus 5y over y for x equals 35 and y equals 5. X minus 5y over y. X equals 35. All right, guys. So the reason why I write this step in purple, the first step, is because I want to remind myself what's the expression? What are my constraints? What is X and Y equal to? This is the way we set up in the college courses, because you are going to see these in other classes after my class. So now let's plug it in. So instead of X, guys, I'm going to plug in 35 minus, bring down the 5. Now remember, we know 5 and Y is 5 times Y, right? We know when a number, letter next to it, they're being multiplied. So I'm gonna do a parentheses for multiplication and plug in 5 for Y. Over, whoa. That was awkward. Okay, over Y, and Y is just 5. Does everyone see how we plugged in X and Y so far?
Excuse me, sir. Instead of putting parentheses, I just put times 5.
Now, how did you write times, Sarah?
Well, I just put like a little dot.
The dot, that's completely fine. Yes.
Okay.
It's the same thing. Now, if in case you ever want to double check now, because remember I used to teach high school, I always if you have a highlighter, I always have my students highlight, okay, well, what did you plug in? Always highlight so you can make double check. Does everything look good? Because if we plugged in something incorrectly, the answer will not be correct. So you have to make sure the plugging in is good. So now we're gonna do PEMDAS. So now we have to use, and now it's a fraction bar. So how do we do PEMDAS with the fraction bar? How do we simplify this?
You have to start from the top, then the bottom.
Top and bottom. So let's go ahead and do the top first. So then we have 35 minus 5 times 5. So now parentheses, this P means that there's something inside of parentheses. These parentheses just means multiplication. It's like the dot. So this is not P. So we're good with P. There's nothing to simplify. There's no exponents. So now we multiply and divide from left to right. So 35 minus 5 times 5. So we're going to go ahead and multiply these two. 5 times 5 is what, ladies and gentlemen?
25.
That is correct. So we're done with multiplying and division. Now we add and subtract from left to right. What's 35 take away 25? 10. That is correct. So now the top is done. Do we have to simplify the bottom, ladies and gentlemen? Yes or no?
No.
No, because it's already just a number. Excellent. Good job, Iris. So we already have the bottom down. So let's go ahead and make the fraction that we know. So it's 5. So it's going to be equal to 10 over 5. And what's 10 over 5?
2.
2.
And we are done. Good job, ladies and gentlemen. All right. Any questions on how we did the example? You guys ready to try the practice problem on your own? All right. I'm gonna go ahead and give you guys 1 or 2 minutes for the practice. 1 or 2. What do you think? All right, 2. All right. Thank you, Sarah. 2 minutes starting now. Good luck. Let's try something different. For when you finish practice 3, type your answer in the chat, but only look at the chat when you're done. Don't be sus. Ooh, people already got it. Nerd status. And don't be afraid to be honest with your answer. Like if you didn't get what everyone else is typing, that is okay. You know, it's okay to be different because that way we can fix what you made a mistake on. Excellent, 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 guys. All right, timer's almost off. Yep. Excellent, guys. For everyone who got a 4, you got it correct. The answer is 4. Does anyone have any questions or concerns or comments on this example or practice problem? Excellent, guys. Excellent, excellent. That make me proud. All right. Are there any questions? Right, we're good. All right, let's see how it gets when it gets more challenging. Let's see if you guys can keep it up. Example 4. Let me give you that 1-minute timer to set it up. Now, if you want to start the example on your own, you may do so. Now, on this one, you may, it would benefit you guys to have a parentheses around the X value. That's my word of advice. It's a good habit to start. Whenever you have an exponent on a variable and you're plugging in, always put parentheses around the number you plug in. Because it matters, ladies and gentlemen, it matters. Excuse me. Such a judger, Sarah. I didn't know coffee had gas. All right, so this is the example. So I am going to start working it out so y'all can see my process behind it. So I have my expression. I have what X and Z are equal to. Let's plug in. So X squared. So it should be 5 squared. Plus Z. Z is 4 plus 4 minus 3. And now we simplify using Pemdas. Now I'm not going to write Pemdas because you should have it in your notes, or if you're not comfortable with how to simplify, you should be writing Pemdas to the side. Oh, and I just started writing it. Peer pressured. But anyways, you do as you wish. This is your learning. Okay. Are there any parentheses that we can simplify the inside? No, listen. And then E, are there any exponents we can evaluate? Yeah. What's the exponent?
5 squared.
What's 5 squared?
25.
Excellent, because it's 5 times 5, right? So then we get 25, bring down everything else, ladies and gentlemen. Now, can we multiply or divide anything else, guys?
No.
So now we
No.
move to the final step, which is add and.
Subtract.
So let's go from left to right. So what do we do first?
Oh, wait, wait.
Add 25 plus 4.
Yep, and what do you get?
29.
Minus
3.
3, which our final answer is?
26.
Yep, and we are done. All right, let's see how y'all do with practice 4. Ready? I'm gonna go ahead and give you guys 1 minute or 2 minutes for practice 4. 1 or 2. Let's try 1, and I can add another one if I need another minute. Starting now. Good luck, everyone. Ah, the plot thickens. Remember, type your answer in the chat, guys. We have two different answers so far, so that's gonna be a debate. Let me go ahead and plug it in real quick. So we get 25 minus z cubed plus x semicolon z equals 2 and x equals 1. Let's plug in. So we get 25 minus parentheses 2 cube plus 1. All right. So for order of operations, what did you do first, ladies and gentlemen? What's the first thing you simplify in this step? Oiva.
Parentheses.
Yeah, the parentheses. So the two is already by itself, so we're good with parentheses. So now, are there any exponents, ladies and gentlemen?
Yes.
Yeah, 2 to the power to the third power, which is 2 times 2 times 2, which is what, ladies and gentlemen?
86.
Ah, that's 3 times 2.
Okay.
So it's 2 times 2 times 2. So 2 times 2 is
4.
times another 2.
8.
8 plus 1. What symbol should I bring down though in front of the 8 though? What's this in front of the parentheses?
Minus.
A minus. Is everyone with me so far?
No.
So, okay. So we plugged in the 2 for z and we got 2 cubed, which is 2 times 2 times 2, which is 8. Everyone understand that part, correct?
Yes.
And then we bring down everything else, 25 minus plus 1. Now we're done with exponents. What's the next step we do in order of operations?
Multiple minus.
Yeah, multiply and divide. Are there any more multiplying or dividing here?
No.
No, so we're done with step 3. Now we what? Add and
Subtract.
from left to.
Right.
So which one, what am I gonna do first? 25 minus 8 or 8 plus 1?
25 minus 8.
Which is
17.
17. Bring down the plus 1 and our final answer will be
18.
there we go. Do you see that, Sarah? Did you catch your mistake? Okay, good, good, good. Anyone else have any questions for me? All right, let's do the next example. Now this one is, now there's a word problem to it. So I'm gonna give you 2 minutes on this one. Go ahead. So this is actually the conversion equation for Fahrenheit to Celsius. So how this works is you plug in the degrees in Fahrenheit into the equation and it'll give you the Celsius, the temperature in Celsius. So the same thing after you write the problem, you write it again, 5 parentheses f minus 32 over 9 semicolon f equals 86. Would anyone like to tell me what will be the first step after this line? What do we do with the expression and the f value?
86 minus 32.
Excellent. So we're gonna plug in 86 for S. We get 86 minus 32 over 9. Can someone tell me what 86 minus 32 is?
270.
270 for the bottom for 86 minus 32?
54.
54, because we're gonna do, remember, we're doing the steps, guys. So it'll be parentheses 54 over 9. Remember, we're doing the steps from Pemdas. So we did parentheses. Now what's next? On top, we do 5 times 54, which gives us what?
270.
So 270 over 9. When you divide that, what do you get?
30.
A equals to 30 degrees Celsius. And we're done. So 86 degrees Fahrenheit is the same thing as 30 degrees Celsius. What questions does anyone have regarding these steps? This example. Excellent. You guys are getting the 30. Excellent, excellent job. Thank you guys for typing in your answers in the chat.
I'm just still copying the question.
No worries, Sarah. You're good. Let me know when you're good, okay? All right. Let's go ahead and try the definition now. So now we're going to talk about equations. So we just did algebraic expressions. We talked about variables. We're now going to talk about equations. So the definition of a solution is a value for the variable that makes the equation a true statement. So we're not solving it yet, but what we're talking about, what is a solution of an equation? So I'm gonna go ahead and give you guys 2 minutes to write this slide down before we get started. So a solution is a value for the variable that makes the equation a true statement. Example 6. Determine whether 6 is a solution of the equation 4 parentheses x minus 3 parentheses equals 12. Now we're not solving it yet. If you know how to solve it, perfect. You can find out yourself if it is a solution or not. But this lesson isn't based off of solving. It's about checking. Do you know how to check if something is a solution of something? So the first step to do, so example 6, step 1. I'm just writing the steps. I'm not starting it yet. So step 1, we're plug in possible solution. Evaluate. And simplify. All right, I'm gonna get started. So we're checking if 6 is a solution of this equation. So first I'm gonna go ahead and the equation's right here, so I'm not gonna rewrite it again. So instead of x, I'm gonna plug in 6. It'll be 6 minus 3 parentheses equals 12 with a question mark on top of my equal sign. I put a question mark on top of the equal sign because we do not know if 6 is a solution. We do not know if the left side equals the right side. We do not know. We're doing this to check if it is a solution. So we're going to simplify the left-hand side where we plugged in the x to see if it equals the right side. For 6 to be a solution, the left side needs to simplify to a 12 because 12 does equal 12. That's a true statement. If we get something else like 5 equals 12, that's not true. 5 does not equal 12. So that's false, not a solution. So let's find out. So now we simplify the left side using Pemdas. So what do we do first to simplify the left side?
6 minus 3.
Which is what? It's 3. Bring down the parentheses. What's 4 times 3?
12.
Does 12 equals 12? Yes or no? Yes. So now we put a check mark on top of the equal sign and write the word true and say 6 is a solution. And we are done. Did everyone see the process of what we did to check if it's a solution? Does everyone follow with me? Are there any questions? All right. Example 7. Go ahead and give you 1 minute to set this up. Example 7 says, determine which numbers in the set 26, 40, and 20 are solutions of the equation 2n minus 30 equals 10. So it wants us to test all 3 of these numbers. So these are all possible solutions. All right, so we're gonna do what we did in the last example, but how many more times are we gonna try it now? 3 different times. So let's go ahead and do the first one. The first case is we're gonna try out n equals 26. We're gonna do that one first. So then we have 2n minus 30 equals 10. And let's go ahead and substitute the n for 26. So then we get 2 parentheses 26 minus 30 equals 10 with the question mark on top of the equal sign. Once we plugged in the 26 for n. We did this because do we know if the left side is equal to the right side? Do we know? No, we don't. We're finding out right now as we speak. So how do we simplify the left-hand side, guys? How do we simplify it? Using Pemdas, right? So what do you do first?
26 times 2.
Which is? 26 times 2 is
52.
52. Bring down the minus 30 equals 10. Now, what do we do next to simplify the left-hand side, y'all?
We have to subtract 52 minus 30.
And what do we get? That is correct. We do subtract and we get 22. Now, quick question, class. Does 22 equal 10? Yes or no?
No.
So then we draw a line through the equal sign. Draw a line. That means 22 does not equal 10. So is that true or false?
False.
False. So then we can say that 26 is not a solution. Did everyone see how we did that? So now we're gonna do the same thing now for the next number in the set. What's the next number in the set?
40.
40. So then we do n equals 40. So I'm not gonna write the equation again, so I have it there. So it'll be 2 parentheses 40 minus 30 equals 10 with a question mark on top. So how do we simplify the left side? Talk to me.
Multiply the 2 into the 40.
Which is
80.
80, bring down the minus 30. What's 80? Take away 30, y'all.
50.
Does 50 equal 10?
Nope.
Nope. So that's false. So we can say 40 is not a solution. Thank you so much. Now we're on the last one, 20. So it'll be 2 times 20 minus 30 equals 10 with a question mark on top. Run me through the process, guys. What do we do first?
2 times 20,
Which is,
40.
thank you. Then we have 40 minus 30 equals 10. What's 40 take away 30? We get 10. Does 10 equal 10? Yes or no? 10 doesn't, yeah, it does. So that's true. So what can we say about n equals 20? 20 is what? Is a solution. Everyone with me on this example, ladies and gentlemen. Now, this is an alternative way you can do this to check your solutions, guys. This is something I highly recommend for you to do in the beginning. If you're a beginner in solving equations, I always recommend you check by plugging them in, because you can do this to any type of equations. You can do it to harder equations. They will be seeing this class later on. It's pretty cool how math works. Are there any questions on this example? Does anyone need more time to write any of this example? All right, we're almost done with the notes, guys. 2 more slides. So go ahead and I'm gonna give you about 3 to 4 minutes, actually 4 minutes to write down this table. This tells you the different words that you're gonna see to see the operation and expressions and word problems. So I'm gonna go ahead and give you 4 minutes to write this down, starting now. You can make a table if you want, or you can just do columns in your notebook, however you want to do it, guys. But I highly recommend for you to have these phrases for each operation. All right, does anyone need more time to write the example and the chart? Anyone need more time?
I do.
All right, I'm gonna go ahead and give you guys another 3 minutes. Just because it is a lot to write. All right, guys. Anyone need more time? All right, I'm gonna go ahead and get started, ladies and gentlemen. So example 8 is being able to go from words into an algebraic expression, guys. That's pretty much the goal here. So I'm gonna start here with A. So write as an algebraic expression, use X to represent a number. So wherever you see the word number, it's the letter X. So A is 7 increased by a number. Increased by is what operation? Increased by.
Addition.
Addition, add. So it'll be 7 plus is increased by a number. What do we use for the phrase a number? What letter?
X.
X. And we're done with A. 7 plus X. 15 decreased by a number. Decreased by. It's minus. So it'll be B is what's gonna go first?
Would it be 15 minus X?
It would be, yes, it'll be 15 minus x. Because it says, look how it reads. So it says 15. And then it says what? It's decreased by. So if it's being decreased, it's going lower by a number x. It's all about the wording in the order, okay? Let's look at C. What does C say? The product of 2 and a number. So product is what operation?
Multiplication.
So it'll be 2 times a number. A number is x. 2 times x is the same thing as 2x. All right. D, the quotient of a number and 5. What operation is quotient?
Divide.
Divide. So what's first though? A number, right? So it'll be x divided by 5 or x over 5. Now E. 2 subtracted from a number. 2 subtracted from a number. So how would we write that? 2 subtracted from a number.
X minus 2.
Excellent. X minus 2. Because look how it reads. It says 2 is being subtracted from a number.
Wouldn't it be like 2 minus x? Or the same?
It's not the same thing. 2 minus x is not the same thing. So look at the wording, Sarah. It says as 2 is being subtracted from a number. What if I told you, hey, Sarah, 2 is being subtracted from 10? 2 is being subtracted from 10. What would you write? 2 is being subtracted from 10. Or what's the answer of that? 2 subtracted from 10.
8.
8. So what did you do in your head? 10 minus 2. So it should be x minus 2. Do you see that?
Yes.
Okay, good question. All right. Are there any questions on example 8, guys, on what we did? Any questions? All right, let's see. We have one more slide, guys, the last slide and the last practice section. So go ahead and write this helpful hint, guys. Write the word helpful hint. And go ahead and write this down. I'm gonna go ahead and give you guys about 6 minutes to write down the helpful hint and then start on your practice problem. Your last set of practice problems. Right, guys, that was the timer for this section. Does anyone have any, let's try it. Let's work through these. Anyone still working on the practice problems, guys? Anyone still working? All right, let's go over them together. So write as an algebraic expression, use X to represent a number. So let's talk about A, twice a number. So we know a number is going to be X, right? So what do we do to twice something? What operation?
Would it be addition?
Did you say addition, Iris?
Yes.
Let me tell you, let me ask you, what's twice of 5?
Oh, it's like 25, like, so it'll be like multiplication.
Multiplication. Multiplying what number exactly though?
5.
Well,
Wait.
was twice 5 was 10, right? What's twice of 4?
Or it'd be
Twice of 4.
16.
Ah, you sure? Twice of 4. So if you see 4 twice, you're not multiplying the 4 and 4, but what's 4 double?
Oh, 8.
Ah, so now, so what? So twice and double are kind of the same. They're synonyms. They're like twins, fraternal twins. So twice and double. So when you double something and you get twice of something, what do you multiply to get that double or that twice? So 4 times what gave us 8? 5 times what gives us 10?
2.
2. Do you see that distinction, Iris? How
Yeah.
doubling it twice is 2 times something. So it's 2 twice the number will be 2 times x, which is or just 2x. Let's look at B. 8 increased by a number. 8 increased by a number. So what's the expression going to be for that? Anyone can chime in. Anyone can share or type it in the chat. What is 8 increased by a number, guys? What's B? What do you think? Ah, thank you, Miranda. We have an 8 plus x. Does anyone agree or disagree with 8 plus x?
Agree.
Agree. Excellent. Excellent. I also agree. Now C. C says 10 minus a number. Would anyone like to share with the class, either muting or chat, what is 10 minus a number?
Would it be like 10 minus x?
Ah, yep. Yep. 10 minus a. Now, if you ever get stuck on this, like, what does that mean? 10 minus a number. Well, tell yourself 10 minus 5. How would you write 10 minus 5? 10 take away 5, right? But replace 5 with a number when a number is x. So as everyone see that 10 minus a number is the same thing as 10 minus x? Always add a number for a sample if you need that assurance, like because right there was a lot of like, is it really 10 minus x? Well, let me see this. 10 minus 5 is 10 take away 5, which is 5. Okay, yeah, 10 minus x. D. Let's see if I can see the difference from D. What's 10 subtracted from a number?
X minus 10.
X minus 10. You see how it reads it though? We're 10 subtracted from this number. What's 10 subtracted from 50? It's 40. So we did 50 minus 10. Excellent. Now the last one, E. The quotient of 6 and a number. How would you write this?
X
Would it
divided-
be? Oh, sorry, you can go first.
X divided by X.
6 divided by X. If I wanted to write it as a fraction, what will go on top and what will go on bottom?
Would it be x over 6?
Great question. I heard X over 6. Actually, no, it would be 6 over X. 6 or whatever goes first will go on top. So let's do this. Let me change my color up. I want you to write this in your notes. So this is a note. Note. Let me scroll down a little bit. Give me a second. Edit. Page extender. Let me move this over here. So no, it's always gonna be top divided by bottom. So that way you can write this note. So top of divided by bottom is the same thing as top over bottom. So that way, in case you ever get lost on the homework, you can see, all right, this is the note. The first number in the division symbol will always go on top of the fraction. And then the second thing after the division sign will be on the bottom of the fraction. Does that note make sense, Iris, everyone?
Yes.
Excellent. And guess what, guys? You survived your first lecture of elementary algebra. Give yourself a little round of applause. Now, what questions do we have regarding the lectures we went over today, and any questions about my class? If we have any right now.
Will we be needing any books?
Great question, Miranda. So if you got the code for my math lab, you should have access to the e-textbook online. Do you need the book? Not really, because I'll be doing the notes from the book to help you out for the sections on the homework. Now, if you guys want to really dive into this class, I recommend looking at the book on your own free time. I'm not going to say it's required, but I just know when you read the book and look at the examples and see how the author writes the examples and how they work it out, it kind of adds more experience to you to the class. Does that make sense? But it's not required. It's optional. Any other questions?
Will you be able to post the recording?
I'm gonna learn because I never use Canvas. I've used Blackboard. So once I master, I will be uploading recordings after every lecture. It'll be uploaded within 24 to 48 hours, Sarah. And I highly recommend, if there was a topic that was quick for you or you weren't sure of, rewatch it. Don't watch the whole thing. Fast forward to where you got stuck on, you know? But yeah, I will be uploading recordings. I'll stop recording once I'm done answering questions in case students who watch are like, oh, I'm stuck. That's a good question. Yeah, okay. Are there any other questions about the class? Or me, or for the class, or for me about anything?
I do have a question. My daughter has a dentist appointment Wednesday at 11, so I have to leave at least 30 minutes from where I live. How would I be able to get the rest of the notes?
So great question, Carly. So that's a great question, Carly. So I'm gonna do a couple things. Since we are a virtual class, guys, I would love for you guys to I'm gonna start a discussion post where you write about yourself and what you're doing, like what job you do, you know, if you have a family, whatever. That way y'all can respond to each other and be, oh hey, you know, Carly has a daughter, I have the notes. And someone could be like, Sarah could be like, hey Carly, I can send you pictures of my notes after through my phone, you know, or through email. I want you guys to, because mathematics is a collaborative subject. You don't work on your own, you work together, and we talk it out together, and that's how you learn more efficiently when you work together. So you can either email me, Carly, and or wait for the video to be uploaded and watch it yourself to do it on your own, or you can meet someone from the discussion post that I'm going to start to talk about yourself, so you can meet other students in this class as well, so you can work together.
Thank you.
So I also have little ones too, so I understand what it's like to have, you know, responsibilities outside of life, work, and school. I get it. So just communication is key. Are there any other questions regarding my class or work or assignments or anything?
So you suggest that we should have 2 notebooks, a ruler, and what else did you say?
And a 4-function calculator that's not your phone. That's not your phone. Okay. That way you can use it to do simple calc. Because whenever you move, and what if next semester your math class is on campus? You know, you want to have, because and your professors in the classroom will not let you use your phone for a calculator. So you'd be like, oh, I already had one. Pacheco made me get one. Cool, I'm good. You know. Great question. Any other questions so far? Now, I did get an email about the math prep if we're gonna do it from 11:25 to 11:50. I'm not gonna start that today. Maybe not start it this week, only if we need it, you know, only if you guys tell me, sir, can we work together online? Because I'm still setting up my math lab right now. I'm setting up the due dates and the times for everything right now. So once I get that all situated and we activate it, I will ask the class if y'all want to work together online on your online modules, like your online assignments. Other than that, guys, we'll hopefully have access to my math lab by either tomorrow or Wednesday, the latest, for my math lab.
And is the math lab supposed to be on Tuesdays? I mean, I'm sorry, Mondays or Wednesdays?
So the math lab is actually going to be every Mondays and Wednesdays from 11:25 to 11:50. But sometimes if the lecture was smooth, you guys picked it up, you guys understood it and everything, then I'll ask, hey, do you guys want to work together online? Like I'll be available to answer questions, or y'all can work offline. I'll give the option too. All right. So was my lecture decent? Was I too quick? Is there any feedback for me so I can be better for next time? Were the examples helpful? Were the steps good? Are there any, because I can work on I'm always trying to work on my lecturing skills. If you need me to go slower, just let me know and you can email me privately. I'm all about improving as a educator, as a professor. Other than that, guys, that's it for me. You survived the first lecture, your first 2 lessons. I'm excited for Wednesdays. It'll be a little more packed day since today was syllabus day. Make sure to look over that syllabus. You have my email and number. And if you ever need anything, guys, do not hesitate to email me or text me. But remember, let me know what section you're in and your full name, first and last name. And my number is on the syllabus, guys. If I'm available, I will respond to you. If I'm not, I will respond when I can. Other than that, guys, I appreciate your time. I appreciate y'all's flexibility today. And I had a great time today. I'm gonna go ahead and stop recording.